All right, starting chapter 8, 8.1 and 8.2, we're going to kind of combine these together because the rules are pretty much the same. So in 8.1, we're looking at defining what is a square root. So if we have a number c, we'll consider it a square root of a if you take the c and square it. In other words, multiply it to itself, it's equal to a. Now you got to be very careful on how these examples are written. If they say find the square roots, notice it's plural. What are the square roots of 9? What number times itself equals 9? And a lot of people say, oh, the square root of 9 is 3. But it's plural. There's got to be another answer out there. Negative 3 times negative 3 is also a positive 9. So the two square roots are positive 3 and negative 3. Now, we're also going to define what is a principal square root. These will always be the positive value. So what does it mean to be a principal square root? Well, that means that the square root symbol is already in the expression. So if I ask what is the square root of 25, that's the principal square root. They want a positive 5. If they write a fraction and they got a square root in the numerator and the denominator, square root of 49, 7 on the top. Square root of 64 on the bottom, 8, 7/8. Here we have a negative being multiplied to the square root of 36. If I just cover up the negative, the square root of 36 is 6. Now multiply it by the negative, negative 6. Here we have the square root of 0.0144. So if you're working with decimals, I notice that there's 4 decimal places. Well, if I need a number times itself to give me 4 decimal places, each number has to have 2 decimal places. So I see this as the square root of 144, which is 12. Now put 2 decimal places on it, 0.12. 0.12 times 0.12 has 4 decimal place answers. 12 times 12 is 144. We put a 0 to fill in that spot. There's our answer. So anytime it's a square root, you have to have an even number of decimal places. Cut it in half. 4 places divided by 2. Your answer has to have 2 decimal places. All right, simplifying. You got to be very careful here. These are going to be very tricky. Remember, all principal square roots, they give me the square root symbol. We must guarantee a positive answer for all of them. So the square root of 13 squared is 13. A lot of people see, oh, the square root symbol, the square symbol, we cancel each other out, we get a 13. And then we carry that over to this problem, and we cancel the square root with the 2. But that's not equal to a negative 4 because it's not a positive answer. So what technically happens here is the negative 4 is multiplied to itself, negative 4, which gives you a positive 16, and the square root of 16 is a positive 4. It has to be a positive answer. Now we have variable expressions. The square root of the binomial x minus 2. Again, think about canceling the square root in the power of 2, but it's not equal to x minus 2 because I did not guarantee a positive answer. What if my x was a 1? 1 minus 2 is a negative 1. It's not positive. So I need to guarantee this answer to be positive, and to do that, you put absolute value bars around it instead of parentheses. Now it's a positive answer. Here we have a trinomial. We need to factor it. All right, so we need to have 2 binomials exactly the same. What 2 numbers multiply to be 16 and add up to be a negative 8? X minus 4, x minus 4. That's x minus 4 squared. Take its square root. It's x minus 4 again in absolute value bars. Again, guaranteeing that it's positive. So, while we're here, let's create the absolute value bar rule. You must start with an even root, square root, fourth root, sixth root, an even number on this ledge. So in other words, all these square roots, you can put a 2 on those ledges. Then we take the even root of x to some power. We divide the root into the power, and if you get an odd power, on your variable or variable expression, you put absolute value bars around it. All right, so here we have the square root of x to the 8th, and we're going to use the Cosinta rule. Again, put a 2 on that ledge. That's the root. The Cosinta rule says 2 goes into 8 how many times? 4 times. That's x then to the 4th power. We do not need absolute value bars. We did start with an even root, but we ended up with an even power. No absolute value bars needed. The square root of x to the 6th. Cosinta rule. 2 goes into 6 3 times. Now, even root, I end up with a variable to an odd power. I need absolute value bars around it. More variables, more checks. Square root, 2 goes into 10 5 times. 2 goes into 12 6 times. 2 goes into 4 twice. So you have to put absolute value bars around the whole expression, or you can put it just around the x to the 5th. Both of these are considered correct in my book. All right, now, how do I know when I need to put absolute value bars? Really must pay close attention to the directions. You have to read the directions for every problem. If the directions indicate that the variable represents positive values or non-negatives, then there's no absolute value bars are needed. But if the directions make some kind of statement that the variables represent all real numbers, then they can be negative. You need to think about absolute value bars around the problem. All right, next we're going to talk about a cube root. Same type of definition. The number c is a cube root of a if now c to the 3rd power is equal to a. So that means if we take the cube root of a, it's equal to c. So if we take this 8 and we break it down, 2 times 4, 4 breaks down to 2 times 2, we can rewrite this as the cube root of 2 to the 3rd power. Those two cancel out, gives me a 2. 27, do the same thing, 3 times 9. 9 is 3 times 3. This is 3 3's, so 3 to the 3rd power and the cube root cancel out to a 3. Cube root of 64, be careful. 64 is also a perfect square, and it's also a perfect cube, so it's not 8 and 8. We could go 8 and 8, but then we got to break it down. We want to go 4 and 16, and 16 is 4 and 4. There's my 3 4's. The cube root of 4 cubed, or 64, is a 4. Now, the cube root of negative 8, we can have negatives now because 3 negatives multiplied together. Negative 2 times 4 is negative 8. 4 can be negative 2 times negative 2. There's my 3 negative 2's to the 3rd power. We can have a negative answer for odd roots. So cube root, 5th root, 7th root. Any odd root can have a negative answer. All right, the cube root of y cubed, Cosinta rule. 3 divides into 3 once. So y to the 1st, we don't need absolute value bars because we're not starting with an even root. Now again, remember, here's the cube root of a negative x to the 6th. We can have a negative here. So 3 goes into 6 twice, which is x squared. Just take out the negative. So anytime you have a negative inside of a cube root, you will have a negative answer. So if you want, just grab that negative, move it out into your answer right away. You can do that for every odd root. 3, cube root of z to the 9th. 3 goes into 9, 3 times z to the 3rd power. Cube root of negative 27, x to the 15th. Okay, don't recreate the wheel. We're going to have a negative in my answer. 27 was 3, so it's a negative 3. 3 goes into 15 5 times. So x to the 5th power with a negative 3 attached to it is my answer. All right, nth roots. Nth root is c to the nth power equals a, then the nth root of a is equal to c. The nth root, this word root here, can also be replaced with index. Inside is called the radicand. So what we want to do is we want to break this down. So 32, we want to break it down to one number multiplied by itself 5 times, because that's my root. Well, 2 times 16, 16 is 4 and 4. Pair of 2's out of each 4. There's 5 2's. That's the 5th root of 2 to the 5th. That's a 2. The 5th root of negative 32, don't recreate the wheel. Remember we said odd roots can be negative. My answer is a negative. 5th root of 32 is 2. It's a negative 2. Negative 4th root of 81. Break the 81 down. 9 and 9. Pair of 3's in each 9. There's 4 3's. That's 3 to the 4th power is 3. The 4th root of 3 to the 4th. Cancel out gives me the 3. Then multiply that negative to it. Now, if I put the negative on the inside of a 4th root, that cannot be possible. 4 negatives multiplied together must equal a positive. There's no way this can be done. The 7th root, 7 goes into 7 once, y to the 1st. Be careful again, 6th root, 6th power, just don't cancel them out. Remember, all even roots must be positive. So that negative x to the 6th power is 6 negatives multiplied together, which gives me a positive x to the 6th. Now the 6th root of x to the 6th is just x to the 1st. And because it started as an even root, ends with an odd power, absolute value bars. Again, the directions will say, let your x's represent real numbers. Ding, 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 they can be negative, absolute value bars. If my direction said, let the variables be represented by positive numbers, I don't need them. 9th root of x minus 1 to the 9th power. 9 goes into 9 once. I do not need absolute value bars because I did not start with an even root. Even root 10. The 10th root of x plus 4 to the 10th power becomes x plus 1 to the 1st power. Even root, odd power. Ding, ding, ding. We need absolute value bars. Now, please don't think you can do the following. Don't think you can say, well, I'll just put absolute value bars around anything or everything. If you do that, guaranteed it will be wrong. All right, now I want to grab my calculator here real quickly to show you where to find these roots in your calculator. Oh, I hate how long this takes. Here we go. All right, so we want to go to the face of your calculator, left-hand buttons, left-hand buttons. Let's make this a little bit bigger. We'll clear this out. Here's your square root right above your x squared. Your cube root is underneath your math button. It's choice number 4. Your nth root has this little x on it. Now, on some of your calculators, when you choose option 5, enter. The more updated calculator will put a text box right here and a text box in the inside. Now, if your calculator puts A and S up there, you have to put in the root number first. Okay, so the 4th root of 81, 3. Now, you can also type it in the 4 first. Math, ask for number 5. And you'll see what I mean. If you got an older calculator, see how it took the 4 and put it on the root spot? And then we put in our 81, you still get the 3. And just to show you what happens when you do put a negative inside the negative 81 that we looked at, your calculator will give you an, oops, I'm in complex mode. Let me change that mode back to real numbers. I want you to see the error message that you will receive. So let me copy that statement. You get an error message, non-real answers. If you hit go to, they give you that option, it will say it doesn't like this number. It puts the cursor right after what it doesn't like. Doesn't like negative 81. All right, so there's 8.1 and 8.2.